All right, in this lesson we're going to be learning about parallel circuits. But before we get to the parallel, just a quick review of Ohm's law in series circuits. And what makes this a series circuit is there's only one path for electrons to flow. Now here I just have one resistor. I could have multiple resistors or multiple components, light bulbs, speakers, whatever you want to put in there. But it just has one path for current to flow. Now to solve for any of these, as long as we've got two of our numbers, as long as we've got voltage, resistance, and or current, we can find the third one. So here, if we're looking for volts, I cover up my E, and it's going to be I times R. If I'm looking for my current, I cover up my I, it's E divided by R. And if I'm looking for my resistance, I cover up my R, it's E divided by I. All right. So on this one, I'm looking for my current. I've got voltage and I've got resistance. So I cover up the I. I've got 20 volts divided by 50 ohms. So I can use my calculator and just do 20 divided by 50. And I get 0.4 amps. Okay, so that's all there is to the series circuits. Now we're going to take a look at the parallel circuit. Okay, here I've got two paths. Now I've gone on ahead and made both of these resistors the same. I've got 50 ohms. When we had one path for the current to go through, we came out with 4 amps of current. Now I've got two paths with the same resistance, so I should be able to get twice as much current going through there. Think of it kind of like, you've got a checkout lane. If you just have one cashier and one line, then you can get a certain number of people through per minute or per hour. If it gets crowded, they open up that second line, and now we can get twice as many people through, assuming the people have the same amount of items and the cashiers work at about the same speed, we can get twice as many through. Could be, one cashier slower than the other, so it might make a difference. But here, both of these resistors are the same, so we should be able to get twice as much current going through as we did when we just had one resistor there. Now, there's actually two ways that we can get the total current if we're given the resistors and the voltage. Right, the first way is we need to get our total voltage. Now we've got this equation up here. 1 over our total resistance equals 1 over each of the resistors that are in parallel. For our equation, we've got 1 over RT equals 1 over 50 plus 1 over 50 so I've got 1 over RT equals, now if you're using a graphing or scientific calculator, it's going to do order of operations for you, so I can just type in the 1 divided by 50 plus 1 divided by 50 and that's going to give me, whoops, let's go back here. That's going to give me 0.04. Now with this 1 over my total resistance equaling this number, all I have to do is take the reciprocal of it. That's like having this over 1, so if I flip both of them over, we take the reciprocal, I've got RT over 1 equals 1 over 0.04. And the calculator has a button that will do that for us. This x to the negative 1 button. So on your calculator, if you've got x to the negative 1, if we raise something to the power of negative 1, it takes the reciprocal. So I just hit that button, so it's got my answer to the negative 1. I push enter. And so my total resistance, my RT, equals 25 ohms. Okay? So my total resistance will be smaller than my smallest resistor. Okay? Now the 25 ohms makes sense because I got half of them going through this 50 ohm resistor, half going through this 50 ohm resistor. But we're not always going to have the same value for these. All right. Now to get my total current, cover up the I. So I'm going to take my 20 volts divided by my total resistance, which was 25 ohms. I'm going to do 20 divided by 25. And that gives me 0.8 amps. So I'm getting twice as much current through it because I opened up that extra line. Now another way we could do this, change my color here, is calculate the current for each branch and then add those together. And with parallel circuits, my voltage stays the same across each branch. The current gets divided, the voltage stays the same. So for this first resistor, I've got 20 volts divided by 50 ohms. And we know this is 0.4, but we can just go ahead and double check that, use our calculator. 20 divided by 50, and I get 0.4 amps. Then this is the same. I'll go ahead and set it up. 20 volts over 50 ohms. I don't need to use a calculator because they're both the same. Now if I add these together, because I'm going to take the people going through this line, add them to the people going through this line to get my total. 0.4 plus 0.4 gives me 0.8 amps, which is the same that I got up there. So you can use either method, just whichever one you prefer. All right, so let's take a look at another one. And I'm going to use a different calculator on this one that has a different key on it. All right, now I've got 18 volts. My resistors have different values. Now I know that my resistance is going to be less than 75. All right, I'm going to go ahead and go through both methods again. First, I'm going to find my total resistance. Using my formula up here, I've got 1 over RT equals 1 over 75 plus 1 over 150. So I'm going to use my calculator. 1 divided by 75 plus 1 divided by 150. That's going to equal 0.02. So now I want to get my total resistance by taking the reciprocal. Now this one doesn't have the x to the negative 1. I've got x squared, I got the square root, I've got raised to the power, but I do have this 1 over x right here. So if we use that 1 over x function, that's going to take the reciprocal. Now to use this, since it's above the button, that means we push the second, or it might say shift on your calculator. Push the button, so that's 1 over our answer. Push enter, and I get a total of 50 ohms of resistance. Now I'm looking for I. So I cover up the I. It's E divided by R. So I've got 18 volts divided by 50 ohms of resistance. I've got 18 divided by 50. And I get 0.36 amps. All right. Now when we use the method, we're going to calculate the current going through each branch. I've got 18 volts here, 18 volts here. Again, I'm going to use Ohm's law, E divided by R for each of the branches. So I've got 18 volts divided by 75 ohms. Got 18 divided by 75. And that's going to give me 0.24 amps going through this one. Now I'm going to take my 18 volts divided by my 150. Divided by 150. And here I get 0.12 amps. Then to get the total, I add these together. 4 plus 2 is 6. 2 plus 1 is 3. We bring our decimal down. So I get 0.36 amps, which is the same that we got up here. Okay. So again, we can use either method in solving these. All right, this one's a little bit different. We're going to have to do some math on this one. I'm going to go back to the other calculator. Whoops. Okay. So we still got our two paths. We've got a 75 ohm resistor. I don't know what this one is. I know my total current is 33 amps. A couple of different ways we can solve this one. One way, I'm going to find out how much current I have going through this one. So I've got my 18 volts and 75 ohms, so I can find my current here and subtract it from my total current. So if I take 18 volts divided by 75 ohms. 18 divided by 75. And that gives me 0.24 amps. Okay, so I've got 0.24 amps going through this branch. I've got a total of 33 amps going through the whole thing. So what do I have going through here? Well, I can take my 33 amps, I'll just do this here, 33, or my 0.33, sorry, minus my 0.24, and you can just use your calculator. It's pretty easy to do by hand, but we can do 0.33 minus 0.24. And so that's going to leave me with 0.09 amps going through this one. Okay, so now I know how much current I have. I know that we have the 18 volts because the voltage is the same across all the branches. And so now I can find my resistance. So I cover up the R. It's E divided by I. So I've got 18 volts divided by 0.09 amps. Now before we do the division, do you think this resistor is going to be bigger or smaller than the 75 ohm resistor? Okay, because here we've got 0.24, here we've got 0.9. Okay, so looking at this line's slower, so that means there's more resistance here. But let's see how much more. So I've got 18 divided by 0.09. So yeah. So I've got 200 ohms of resistance going through this one. All right, that's one way of solving it. If you really enjoy algebra or math, another way you could solve this is we could set it up. Well, we won't even go through that. We're not going to do that to you. I think that way was the easiest way. We could find our total resistance. I'll go ahead and just real quick since I started it. Okay, so to find my total resistance, I cover up my R. It's E divided by I. So I've got 18 volts divided by 0.33 amps. So we've got 18 divided by 0.33. So I've got 54.54. I'm going to go ahead and take this out of ways because, of course, any rounding we do, it's going to change our value a little bit. All right. So then we could take our 1 over 54.5454 equals 1 over, then we've got our 75 ohms plus 1 over, oops, not RT, 1 over R2. So what we'd actually do on this one is subtract our 1 over 75 from both sides. So I'll use my calculator. Got 1 divided by 54.5454 minus 1 divided by 5. Okay. So now I've got this long decimal right here. I want to take the inverse of that. And so I get 199.999 equals my R2, which we rounded this off, that 199.99. That's going to round off to our 200 ohms that we got before. All right. Here I want to know what my total current is, and I want to know what my total resistance, and I need to know my total voltage. All right. So it seems like we've got a lot missing there, but we do have enough information to solve this because I know that my I1, this isn't my total current, my I1, the current going through this first resistor, which is 400 ohms, is 0.04 amps. So I can find my total voltage right there. So here I'm looking for voltage. So it's I times R. So I'm going to take my 0.04 amps times my resistance of 400 ohms. I got 0.04 times 400. So I've got 16 volts. Okay. Now that I know I've got 16 volts, I've got 16 volts across this resistor. So here, I can find my current. So I'm looking for I, so I cover up the I. It's E, my 16 volts. Divided by my resistor, which was 600 ohms. I got 16 divided by 600. And I don't want to have to round off again, so I've got 0.02, I'm going to just say 667 amps. Okay. So now I know the current going through this branch. I know the current going through this branch. So I just add them together. So I'm going to add my 0.04. So I get 0.0667 amps. Okay. Or you could round that off to 0.07 or 0.067, depending on the instructions. Okay, so we've got our total current. We've got our voltage. Now I just need to find my total resistance. We're going to use our formula up here. Now go blue. So it's going to be 1 over RT equals 1 over 400 plus 1 over 600. So we take a look at this. 1 divided by 400 plus 1 divided by 600. All right, now remember, this isn't our answer. We're going to hit the x to the negative 1 or that 1 over x button, depending on what kind of calculator you have. Push enter. And so I get RT equals 240 ohms resistance. And if we end up with anything over 400, we know we've done something wrong. Okay. Now, if we wanted to really check our current up here, make sure we did everything right, I'm going ahead and give you a little bit of extra information right here. Let's go ahead and find our total current again using our total resistance and the voltage we came up with. So it's E over R. So I've got 16 volts divided by 240 ohms. Using my calculator, I've got 16 divided by 240, which is the 0.06666 repeating, and then it just rounds it off to 7, but that's actually 6 repeating forever. Okay, it's a non-terminating decimal. So we get the 0.06667 amps, which is the same as we got up there. All right, now we've opened up another cash register, so we've got 3 lines, so we can get even more people through the checkouts and out of the store. All right, so on this one, I'm looking for my total volts, my current, and my resistance. All right, again, since I know the voltage is the same across each of these, if I calculate the voltage on this first branch, that'll give me my total voltage. Now here we've got milliamps, which means I need to move my decimal place 1, 2, 3 places to change it to amps. So that's actually 0.025 amps. Okay, a mil is just a thousandth. That's 25 thousandths of an amp, and this is 10 hundredths thousandths. Okay, so that's 25 thousandths of an amp. All right, so here I'm looking for my voltage. It's I times R. That's going to be 0.025 amps times my resistance, which was 400 ohms. So I've got 0.025 times 400. And so that equals 10 volts. All right. So now I know my voltage. I'm just going to solve this one by calculating the current going through each branch. Okay. Well, actually, since I need to find the total resistance anyway, let's just go ahead and do that. All right. So I've got my 3 resistors here. So again, that's 1 over RT equals 1 over 400 plus 1 over 600 plus 1 over 800. All right, so coming over here to my calculator, I'll say 1 divided by 400 plus 1 divided by 600 plus 1 divided by 800. All right, now I've got this long decimal. I'm going to use my x to the negative 1 button, push enter. And so my total resistance is approximately 184.62 ohms. Now, if we want to round that off to the nearest ohm, that would be 185 ohms. All right. So now I've got my total voltage, which is my 10 volts. I've got my total resistance. So now I cover up current, E divided by R. So I've got 10 volts divided by 184.62 ohms. So 10 divided by 184.62. And I end up with 0.054 amps. Now I can change this to milliamps by moving my decimal place 1, 2, 3 places and making that 54 milliamps. So both of these answers are the same. All right. So we've got our total current, which is our 54 milliamps, our resistance, which was 184.62, and our voltage, which was the 10 volts. So we were able to answer all of those questions. All right, so we're going to work the same type of problem again, just to make sure we got it. All right. No, on this one, they didn't give us the amps going through any of those, so let's just give something a try here. So let's say that our I1 equals 0.2 amps. Okay. So on this one, I'm going to find the total voltage by using the current going through this resistor in this resistor. So I'm looking for voltage, I times R. So I've got 0.2 amps times 450 ohms of resistance. Point 2 times. All right, so I got a big battery on this one. So I've got 90 volts. Right, so I've got 90 volts here and 90 volts here. All right, so we found our volts. Let's find our current going through this third one. All right, so I'm looking for my I. So I've got 90 volts divided by my resistance, which was 350 ohms. So I've got 90 divided by 350. And so I get 0.2, I'll just go 57 amps. All right, finding my R2 and my total resistance and my total current, there's still not enough information here. Okay. So let's say that our total current is, I'm just going to say my I total equals 0.6 amps. Okay. So now I know if my total is 0.6 amps, I know the current going through each of these. I can subtract those to find the current going through my R2. Okay. So I'm going to take my, I'll change colors here. All right, so my total current is 0.6 amps. I'm going to subtract 0.2 amps and subtract 0.257 amps. All right, so I'm going to use my calculator. 0.6 minus, that's 0.6 minus 0.2 minus 0.257. So that leaves me with 0.143 amps. Okay. So 0.143 amps. I've got 90 volts. So here I'm looking for the resistance. I cover up the R. Z divided by I. So I've got 90 volts divided by 0.143 amps. 90 divided by 0.143. And that's going to give me approximately 629.37 ohms. Right? So now I can find my total resistance, the last step along the way. And I'll just use green here. All right, so I've got 1 over RT equals 1 over 450 plus 1 over 629. And I'm just going to round this off to the nearest ohm. Plus 1 over 350. So RT equals 1 divided by 450 plus 1 divided by 629 plus 1 divided by 350. Then after I get that answer, I hit my x to the negative 1, or my 1 over x. So my total resistance is, I'm going to round this off, it's 149.9. I'm just going to say 150 ohms. So that's my RT. The IT I made up, so we didn't really calculate that. I just made that one up, and we got our E, and we've got our R2. Okay, so the parallel circuits are a little bit more challenging than the series circuits, but if you just take it one step at a time, take what you know, plug in the answers that you've got or the values that you're given, and you can calculate the answers. All right, let's take a look at this one and see if we've got enough information to solve all of these. All right. So looking here, we've got I1. I don't like that green. That's a little bit too light for me. Okay. So we've got I1 and R1, so I can find out my total voltage. Okay. So I'm looking for my E, cover up the E, it's I times R. So I've got 0.06 amps times 250 ohms, 0.06 times 0.06. So I've got 15 volts. Okay. So that means I've got 15 volts across each branch. I can't figure out R2 because I don't know how much current's going through there. I can figure out R3 though. So like I said, we're going to go through, we're going to see what we can figure out and what information we've got and see how far we can get. Okay, so for my R3, I'm looking for the current. So I cover up the I. So I've got 15 volts divided by 550 ohms. So 15 divided by 550, enter. So I've got 0.027 amps. All right. Now I think that's actually as far as we can go on this one without more information, because they didn't give us our total current. We don't have total resistance. So I'm just going to make up a number to go in here. So let's say our RT, it has to be smaller than 250. So I'm going to say my total resistance is 100 ohms. Okay. So if I know my total resistance is 100 ohms, I can get my total current. So I'm going to take my 15 volts divided by 100 ohms. And I get 0.15 amps. All right. So now I know the current going through this R2 is my 0.027. I know going through this R1 branch is 0.06. So I just subtract those two from my total. So I'm going to say minus 0.027 minus 0.06. So I've got 0.15 minus 0.027 minus 0.06. And so that leaves me with 0.063 amps. So now I know my voltage going through R2. I know my current. All right, so now I'm going to take my 15 volts divided by my 0.063 amps. Got 15 divided by 0.063. And I'm just going to go ahead and round that off to 238 ohms. All right. So on this one, we had at least one value left out that we weren't able to solve everything without that value. I just made up something, but again, that's the process we go through solving these. All right, we're going to try another one. All right, so on this one, I know there are going to be some issues because we don't have we're missing too many values here. The volts we can find, because again, we got the 0.6 amps and 350 ohms. But to get our total current or our total resistance, we need one of those. So I'm going to go ahead and fill in a total current here. So I'm going to scratch this out. And I want to say we got 0.15 amps. All right. So I'm going to go ahead and find my voltage first. So I've got my 0.06 amps going through 350 ohms on this first one. So I'm looking for voltage. I cover up the E. It's I times R. So I've got 0.06 amps times 350 ohms. 0.06 times 350. That's going to equal 21 volts. All right, so I've got 21 volts here, 21 volts here, 21 volts here. So now I can get my I2, my current, actually that's I3. Put the 3 in there. Okay, so I'm going to take my .21 volts divided by 700 ohms. .21 divided by 700. And that comes out to 0.03 amps. Okay. Now I can find my I2 by taking my 0.15 and subtracting these. So let's change colors here. All right, so I'm going to take my 0.15 amps minus 0.06 amps minus 0.03 amps. All right. 0.15 minus 0.06 minus 0.03, and that's going to leave me with 0.06 amps. So I pretty much know this is going to be 350 ohms because we had 0.06 amps going through this 350 ohm resistor that gave us the 21 volts. I mean, I can go ahead and do the division there. If I can take my, I'll go with green, not real happy with it, but okay. So we're going to take 21 volts divided by 0.06 amps. .21 divided by 0.06, and that gives me the 350, just like this one up here. That's 350 ohms. All right, now I just need to get my total resistance using my formula up here with my calculator. It's not difficult. So I've got 1 over RT equals 1 over 350 plus 1 over 350 plus 1 over 700. Now I've had students who've tried to say, oh, 350 plus 350 plus 700, that's 1400, and they do 1 over 1400. Remember, we can't add fractions unless the denominators are the same. Okay, so don't do that. With the calculators, it's real easy. Just do 1 divided by 350 plus 1 divided by 350 plus 1 divided by 700. I get my decimal. Then I do my 1 over x button, or my x to the negative 1. And so my total resistance equals 140 ohms. Okay, so we've got our current flowing through each of these. Our total resistance, smaller than our smallest. And the more branches we have, the lower this is going to go. If we added the 400 ohm resistor over here, it's going to get smaller because we've got more lines for them to go through. All right, so let's try another one. And I want to go ahead and fill in my R1 right here. Oh, we can calculate R1 because I've got my volts here. So I think on this one, we've got enough information to solve everything. All right, so I'm going to solve for my first resistor. I've got 15 volts. I've got 0.06 amps going through here. I'm looking for my resistance. It's E divided by I. So I'm going to take my 15 volts divided by 0.06 amps. Divided by 0.06. And that's going to equal 250 ohms. All right. So now I can find my total resistance. So I'm going to say 1 over RT equals 1 over 250 plus 1 over 500 plus 1 over 700. All right. Now go back and use this other calculator one more time just in case you've got this 1 over the X button. Still all done the same. 1 divided by 250 plus 1 divided by 500 plus 1 divided by 700. Now to do the 1 over the X, I have to push the second 1 over X, enter. Now it's giving me the mixed number here. So with this one, it's got the fraction to decimal, so I can push second, fraction to decimal, and I end up at 134.6 ohms. And I just rounded off. Okay, so now I can find my total current. Go blue here. So to get my total, since I know my total resistance is 134.6, I've got my voltage. I'm looking for I. I cover up the I. So it's going to be 15 volts divided by 134.6 ohms. (15 divided by 134.6). I get 0.111 amps. And I could have used the 15 volts, calculated how many amps were going through each of these. And I'll just go ahead and do that real quick in case that's the way that you prefer to do it. All right, so I know I've got 0.06 amps going through here. I've got 500 ohms, so I'll take 15 volts divided by 500 ohms. And I'll take 15 volts divided by 700 ohms. I got 15 divided by 500. Then I've got 15 divided by 700. Okay. So 15 divided by 500 gave me 0.03 amps. And this one gave me 0.024 amps rounded off. To get my total current, then I would add my 0.06 amps. So if I add those together, 0.03 plus 0.024 plus 0.06. And because I rounded off, came out a little bit different here, but still pretty close, 0.1114. Okay, if you remember, this was 0.01114. All right, so still pretty close, but again, because I rounded this off, and because of rounding errors, and here I rounded off my current, or not my current, but my resistance. So because of rounding errors, we came out a little bit, but they were still pretty accurate down to the 100th of an amp. All right, last one. All right, so first I'm going to find my R1 because I've got my I1, I've got my voltage, and we know that we've got 12 volts going across each branch. So here I'm looking for R. I cover up my R. It's E divided by I. So I've got 12 volts divided by 0.04 amps. 12 divided by 0.04. So I've got 300 ohms of resistance. So now I can get my RT. I would say 1 over RT equals 1 over 300 plus 1 over 200 plus 1 over 500. One divided by 300 plus 1 divided by 200 plus 1 divided by 500. Get my decimal, then I push my second, the 1 over x. It gives it to me as a mixed number. So I've got this fraction to decimal, so I push the second, fraction to decimal, enter. So my total resistance, and again, I'm going to round this off. I'm just going to round that off to 97 ohms. All right, so that's 97 ohms there. Now I'll just go ahead and calculate the current going through each branch and add those together. Well, actually it's faster. Let's just go ahead. We're going to use Ohm's law. We're looking for the total current. So we just color that out. I've got 12 volts divided by 97 ohms. Divided by 97. I get 0.124 amps. Rounded off. And again, I rounded off my resistance here, and I rounded this off. So they're not perfect, but depending on what you're doing, will depend on how accurate you need to be. But that's how we solve parallel circuits.